All right, if you turn to the back of the series notes, I don't know if you remember, I don't know if I completed the front. 2.7 volts was the voltage of the 12 ohm resistor. The total voltage drop in the circuit, we've already answered that. That's 6 volts. That's the voltage of the battery, right? So that's the general way to evaluate this series circuit. The rest of the stuff on the back is just practice doing it. Right? So let's run through this one a little bit more quickly now, and then I'm going to give you the second one on your own, and you can pause the video and do it for yourself. Here's this circuit here. They've already drawn it for us. They don't always draw the circuits for you. Sometimes they describe it in words and you have to draw it yourself, but this one's already drawn. You have a 6-volt battery connected to a 20 ohm, a 10 ohm, and a 20 ohm resistor. This is in series, one pathway through the circuit. All right? Here's our chart. It's already drawn for us, except we're going to have to put some labels in here. I'm going to say R1, R2, and we have a third resistor in this one, and then the total, right? And I'm going to go ahead and label those up here, R1, R2, and R3. Remember, the first thing we're going to do in this chart is put numbers in here that we don't have to do math for. So let's remember from the front. The first thing we can do is put the total voltage in there, because that's the voltage of the battery. The voltage in the circuit equals the voltage of the battery. That's 6 volts. The second thing we can do is just put in the resistances of the resistors. R1 is 20, R2 is 10 ohms, and R3 is 20. All right. The easiest next thing to do is to get this total resistance. That's what this question is prompting us to do. To do that, remember, in series, the total resistance is simply the addition of all the individuals. So that's 20 plus 10 plus 20, which gives us 50 ohms of total or equivalent resistance. That goes in here. All right, and so again, this table guides us. It tells you where to go. You don't even have to have these questions. What's the total current? Well, that's the next thing we can do right here, because we've got 2 of the 3 values. We can find this current using Ohm's law, I equals V over R. All right, so the voltage is 6, the resistance, the total resistance is 50. 6 divided by 50 gives you 0.12 amps. That is your total current. And remember, in series, if your total current is 0.12 amps, the current is the same throughout the entire circuit. So you can fill in 0.12 all the way up. And then the voltage drop across each resistor, that's what each of these are. All of those can be calculated using V equals I times R. And you want to go ahead and do those real quick. Voltage times resistance for R1, V equals 0.12 times 20. For R2, V equals 0.12 times 10. R3, V equals 0.12 times 20 again. Obviously, I'm not going to do that one because it's the same as the first one. First one, when you multiply those two, you get 2.4 volts. The second one, you get 1.2. And the third one, 2.4 again, because it's the same as the first one. So let's fill those in. 2.4 volts, 1.2 volts, and 2.4 volts. Something that I forgot to mention before that should happen in series. This column and this column, the individual numbers for the resistors should add up to the total. So the resistors obviously add up to the total resistance, and the individual voltage drop should add up to the total voltage drop. And if you add those up, 2.4 plus 2.4 plus 1.2 does indeed give you 6 volts total. And then, of course, as I said, the current should be the same throughout the whole thing. All right. Here's the last circuit for you. You already know how to do this. We've done 2 of these now. You have the circuit. You know what to do in this chart. You know that this is R1, this is R2, this is R3, and the total. You know the steps to take. If you can't remember, go back and look at your notes, or go back and rewind the video and see what to do. But I just want you to see if you can complete this circuit on your own. Just go ahead and pause the video and see if you can do it. All right. Hopefully you came out with these numbers. Total resistance is just simply the addition of the individual 3. That gets you 45. We started out by putting in the individual resistances and added up to 45. The total resistance is the voltage rather. Total voltage is the voltage of the battery. The word total actually should be right here, and that's 12 volts. Current is the next one we got. Current is voltage divided by resistance. That's total voltage divided by total resistance. That's 0.27. 12 divided by 45, and 0.27 goes all the way up. And then the voltage across each resistor is voltage equals current times resistance. In each of these columns straight across, 0.27 times whatever the resistance is, and you get 2.7, 4.0, and 5.3 respectively. All right, so there's that resistor. This is just conceptual information. What happens to the equivalent resistance as more resistors are added? The answer is that the total equivalent resistor increases. Total equivalent resistance increases. That's a very important concept to understand with series circuits, that the more resistances, the more light bulbs we stick in there, the dimmer they get. That means the total resistance goes down, and they get dimmer because of that total resistance. What happens to the current as more resistors are added? The current decreases. And this is all because of the I equals V over R equation. There's an understood 1 under here, and because I and R are juxtaposed to each other, top and bottom, resistance and current are indirectly related. As resistance decreases, current increases, as vice versa. So if we're increasing the resistance here, increase in resistance means a decrease in current because they're directly related. That goes way back to the analogy of the roads going from Frisco to Dallas that we talked about a long time ago. This road provides the greatest resistance to flow, therefore, so resistance in this road is high, therefore the current, the flow of traffic on this road is going to be the lowest out of all of them. Whereas on the tollway, the resistance to flow is very low because there's 3 lanes, which means that the current, the flow, is actually going to be very high. It's the same point with series circuits. The second thing we can do is simply put in the resistances.